All of you ready? बैठना है यहाँ पे, वहां पे नहीं बैठना है तो टेप लगाओ मुंह पे, ठीक है? So we start with quadrilaterals. And our chapter is understanding quadrilateral. Let's try to understand. Now a quadrilateral, as the name says, quad. Quad means four. Okay, quad means four. So it's a polygon, and this polygon will have four sides. Now it can be regular, irregular, whatever it is. Okay. When we talk about a quadrilateral as such, we will say it can be an irregular polygon, and in this case we will have four sides. So let this be anyway. So this is my quadrilateral, and I name my quadrilateral. Look, the way you name is always you follow. What happened? Again, you two are having fun. No, something is there. You are having. See, I can make you sit separately. If you want to sit the way you are, then don't make me police hard. If I police hard, then I'll bring you here. Okay. So the order we always name is either you can go cyclic or anticyclic, that is clockwise or anti-clockwise, your wish, but you don't follow an irregular pattern. What I mean to say is that you go, then this you will follow for all the classes, senior classes from now. You go either ABCD this way or you go ABCD this way. You can't have an A and a B out here. That's not generally allowed. Fine. So we are following a cyclic order in which this is A, this is B, this is C, and this is D. Have you understood? This is a quadrilateral. A quadrilateral will have four vertex. So it has four angle. Four vertex, one is vertex, more than one we say vertices. A quadrilateral has got, yeah, so we have four sides, we have four vertices, and our vertices are A, B, C, and D, which means we also have four angles. And then two opposite vertices will always qualify to form what is known as the diagonal of that quadrilateral. So this is one diagonal and this is another diagonal. Okay. So we will have two diagonals also. So we have two diagonals. And if you are able to distinguish them between their sizes, then the larger diagonal will always be called as the major diagonal, and the smaller one will be called as the minor diagonal. Are we fine till this? If you are able to distinguish between the two sides, I'm not writing here because to me it appears both are same in size. If the sizes are strikingly different, then we will always say one as the major and one as the minor. Are we fine? Samajh mein aayi? No overhead transmission so far? Okay. Now, if I try to look at only one diagonal, say let's consider a quadrilateral. Quadrilateral is written like this. This is the symbol of a quadrilateral. You can make it like a square. Say I have a quadrilateral PQRS, say with diagonal PQRS. So PR will be the diagonal. I'm just considering one diagonal. Take your time. Till that time, let me make my quadrilateral. So this is a quadrilateral. I'm naming it as P, Q, R, and S. And I'm taking my diagonal only as PR. So PR is my diagonal. This is my diagonal. Again, this is what I'm saying. Have you understood? If you consider one diagonal of a quadrilateral, then what do we see? This diagonal actually divides the quadrilateral into two triangles. This is triangle T1 and this is triangle T2. Okay, so you have two triangle formation. One triangle would be triangle PQR and triangle PRS. PQR and PRS. Do you agree? Okay. So out here, if we consider we'll just consider say triangle PQR Okay, then sum of all angles should be equal to 180 degree. Don't you feel so? In a triangle, the sum of all angles is 180 degree. That means angle QPR. Look, children, whenever you try to name a particular angle, then you always include that in the nomenclature in the middle. QPR. Okay, QPR plus, I'm mentioning that as only angle Q plus angle QRP is equal to 180 degree. Fine. Okay. And if you consider triangle, let's say we consider triangle PRS, then in case of triangle PRS, we have angle RPS plus angle S plus angle PRS should also be 180 degree. Do you agree or not? Both the triangles. Now what do? We add both these expressions. So if you add the right hand side, how much do you get? 360 degree. Now look, children, I have got angle QPR. This is angle QPR. I'm trying to add with it angle RPS. So basically, if I add these two, I'm getting angle P. Do you agree or not? Right? Okay. Then I have an angle Q. Then I have an angle S. And if I add these two, I'm basically getting angle R. This actually proves that sum of all the angles of a quadrilateral is 360 degree. Did you understand? So from here we say sum of all angles of a quadrilateral is equal to 360 degree. Anyone who did not understand can ask me the question. I hope you have understood what I have tried to write out here. कौन सा? Plus. Sorry बेटा, ये 7 जैसा लग रहा है ना? Sorry. So this is angle S plus angle R is equal to 360. Did you understand? So it actually divides, and it's not that you need to be only with this what do you call diagonal. You could have taken this diagonal also. Still the relation holds. In that case, we would have got these two separate, and here we would have got an addition. Here we would have got an addition. So what we get to know now is that if you are a quadrilateral, then your sum of all angles will always be 360 degrees. Is that? Square has got 490s. Rectangle has got 490s. It has to be 360. This is generic for any quadrilateral. That's why I made a quadrilateral which is an irregular polygon in any type of shape. Yeah, any type of shape I have made. Are we fine? Then you come and sit here, na? No, that's your fault. You have got so much of seats. In other classes, there are 14 kids who sit here. If you have height issue, you come in front. You want to be with your pal, and then you'll say, I can't see because of your head. That's your. And there's a seat here also. It's 1 hour of study. Let's dedicate that 1 hour to study. Yeah. Are we fine? Okay, shall I go ahead? Yes, please. Please. These are things you cannot forget for next classes also. That is 9, 10. Even in analytical geometry, if you're taking up in grade 11 and 12, these are basics. These have to be very, very clear and right up on your throat so that there is no mistake. If you are a quadrilateral, you've got 4 sides, you've got 4 angles, you've got 4 vertices, you've got 2 diagonals, and then we will always find that the angles always add up to 360 degree. Hey, Ekaksh, your line is not muted. Your microphone is on. Mute it. तो पूरा रात का होमवर्क करके भेज देता है, टाइम का काम टाइम से करता है। हाँ, पूरा एक्सरसाइज कंप्लीट कर देता है उसी बार। चले आगे, shall we? Let's go. Okay. Our next thing will be the special quadrilaterals. which you will be encountering every day in your life. Number one, rectangle. A rectangle is a quadrilateral in which opposite sides are equal in their sizes and adjacent sides are not equal. Further, we say that the angle at the vertices will always be 90 degrees. So what is a rectangle? It's a quadrilateral where opposite sides are equal in length. Adjacent sides need not be equal in length, right? Now look at the way how we represent it. Let's say this is a rectangle ABCD. Okay, these are new things that you will learn. Since AB is equal to BC, you can actually put any symbol. Like say if I put a single dash out here, I will put a single dash out here. This actually shows that this particular is equal to this. However, this is equal to this, but their measurements are not same, so we prefer a different size. Yes, this is. Then you will also find that this is parallel to this. So what you can do is that you can put a line like this, a double arrow here and a double arrow here, which means they are parallel, and these are also parallel. Okay, these are also parallel. And further we get to see that every vertex has a 90 degree, right? So in a rectangle, my features would be opposite sides are equal, right? Then we will say vertex angles are 90 degree each, right? So if this is, then from here we get opposite sides are let's close it now, are parallel. Opposite sides are parallel. Adjacent sides are not equal. So if I represent this with the word L as the length and this with B, and out here we get, what we're trying to say is that L is never equal to B, right, in a rectangle. So a rectangle is a quadrilateral in which the vertex angles, each of them will be 90, which further tells me that the opposite arms will be parallel to each other, they'll be equal to each other. And further we also get to know that the vertex angles are 90 and the adjacent sides need not be equal. Have you understood? Okay. Are we fine? Okay. There's some reason. So what happens now next is, so let's say this is my original rectangle's length. So the bottom length was what, beta DC, right? DC. And this rectangle was standing under scorching sun. So it got tired. So it started to bend on this side. So when the rectangle starts to bend, this rectangle started to bend. What I'm trying to say here is that this rectangle has started to bend. It means this side has come here and this side has come here, something like that. Yeah, that's how you get a parallelogram. So parallelogram's birth comes from a rectangle itself. So there was a little bit of too much of sun and he did not have glucose, so he got tired, and then came the formation of what is known as a parallelogram. Okay, this is a parallelogram, and so this is A, this is B. Now look at the difference in this parallel. Look at the difference. This is more important. When you see the rectangle and the parallelogram, the sides have not changed in their length. They have just stretched. It's like a spring. So this will still be equal to this, and this one is still equal to this one. What got changed is the angle. However, the parallel nature is also maintained. That's why it's called a parallelogram. Do you agree or not? Okay. That's the reason that they are called parallelograms. So in a parallelogram, what happens? Pair of opposite sides are parallel and equal. That's all. Pair of opposite sides are parallel and equal. So this gives birth to the next type of quadrilateral, which is known as a parallelogram. And the parallelogram in symbol is represented like this, double line, and on top we write GM. So our parallelogram is ABCD. And in a parallelogram, always remember, pair of opposite sides are equal and parallel. Pair of opposite sides are equal and parallel. Okay, understood? So now an interesting thing. If I look at this particular statement that I have made out here, this statement, and I try to put this statement on this one, then the rectangle is also a parallelogram, because for parallelogram the criteria is simple. Pair of opposite sides should be equal and parallel. Is the pair of opposite side equal? Yes. So if you try to put this statement out on here, then you get that the parallelogram can be fitted on a rectangle, because to be a parallelogram, now you will understand something that we say in mathematics. We have got a term. That term is known as necessary and sufficient criteria. Necessary and sufficient criteria means, as you go ahead in these type of chapters, you will be asked to prove. You will see that the figure looks like a parallelogram, but you can't say. You have to prove. It's like the court. I know you are innocent, but the court wants proof. You have to give proof. When you try to give proof, to prove a figure is so and so, then what do you have to do? You have to find some necessary and sufficient criteria. That is how the court will accept. This criteria is necessary, and with this much it is sufficient. Like say, I want to prove your date of birth. So a passport is a necessary and sufficient. The passport proves your identity as well as contains your date of birth. So it's a necessary and sufficient. However, your school I-card is sufficient for your ID. It's necessary, but it's not sufficient. I'm not having the date of birth mentioned. Say suppose it's not mentioned, I can't get from that. Are you understanding? So for a parallelogram, the necessary and sufficient criteria is pair of opposite sides should be equal and parallel. And if I superimpose this out here, then it fits here also. That means every rectangle is a parallelogram. But every parallelogram is not a rectangle, because in a rectangle, the necessary and sufficient criteria is not this. It has that angle should also be 90 degrees, and that is where this fellow misses out. So what we write is all parallelograms, all rectangles can be parallelograms, but all parallelograms need not be rectangles. Need not be rectangles. Have you understood? So, are you fine with these two figures? So, the parallelogram was always born out of whom? From a rectangle. The rectangle slanted and drifted on one side. Now, tell me one more thing, okay? Now, let's put our heads into it. If you look at the area of this particular figure, now see, if you look at the area of this particular figure, and if you look at the area of this particular figure, the area does not change. I was like this, I just became. So look, I have lost this much of area. This triangle I have lost by coming here, but I gained this much also. So the areas will always be same. So these two will always have, if it's a rectangle or a parallelogram, obviously with the same dimensions. The dimensions need to be same, means the length of this, and in a parallelogram we do not call it as length, we call it as a base. And the striking measurement for a parallelogram will always be the height. The height. Now this is where children have a lot of confusion. Look, this is height. They say height need not be measured inside the figure. Look at me, I am standing. You can measure my height right with the tape out here, or make me stand and draw a line parallel to the ground and take it to E tower. you can measure my height there also. It's just like a railway track. On a railway track, the distance between the two tracks can be measured any place. Because they are parallel. Are you getting it? So this is known. So don't ever try to think that height always needs to be inside the figure. No, no, no. Height can be anywhere outside also. So this is known as my height. Sorry. This is known as my height. And the height is represented with H. Base is represented with B. Now comes the word that how do we compute area? So a lot of things we are learning right now. The area will be length times breadth, and out here the area will be base times the height. Whether in this chapter or later, you start learning from now itself. The area of a parallelogram is always the base multiplied by the height. Have you studied area of rectangle triangles? Like half base into height? Yeah. You have studied? Okay. So just see how this comes up. Then you'll enjoy this. Never pick up any formula just because sir said that. Never agree to it in that manner. Let's make a diagonal out here. Let's make a diagonal. Are we fine? Now, do you see a triangle BDC? Do you see the triangle BDC? Okay. Now, if I look at triangle BDC, then what is my area? My area will be half times the base into the height. Height can be measured inside the triangle or outside the triangle. Just the thing is, whomever you are taking as base, the height should always be 90 degrees with the base. That's simple. Are we fine? Right. Triangles are, okay, I'm just going on this page just for 1 minute to make you understand. Look, children, you are habituated by seeing area of a triangle as the altitude always inside. It's nothing like that. Make a line parallel to the base. And this, you can measure the height here also. These are also same, right? So I'm just using that concept only. Okay. Right. Let's go back. Now try to look at this. Look at this triangle BDC. What is the area of BDC? Half into the base into the height. Agreed? Clear? Okay. If I look at triangle, the diagonal is dividing. If I look at triangle ADC, then in ADC, what is my ADB? Sorry, yeah. If I look at ADB, then what is my area equals to? Again, half times base. This is the base, same as size, into the height, the same height. Agreed? And if you try to add these two, this triangle area plus this triangle area, you get the area of the parallelogram ABCD. Isn't it? So half BH plus half BH is 1 BH. That's why the area comes B into H. पहले समझो, रट्टू तोते की तरह पढ़ के मैथ्स नहीं होता है. Not like a parrot. Did you enjoy this part? Area of this triangle and area of this triangle.
What if we make the parallelogram?
Any way you make it, your wish. He's confused. Okay, let's see. Any way you make it. All right. So this is my conventional parallelogram. Okay, just try to see. I'll do it with both. This is my conventional parallelogram. The concept of height. Let's see the concept of height. So I'm extending this. I'm extending this. Think that they are the railway tracks. Okay. So one way of measuring height would be, one way of measuring height is that you straight away find the height here. No issues. You can find the height here also. No issues. Agreed? Is your concept clear? Now what we do some jadoo tona with this one. Okay. And we try to rotate this. Let's say the parallelogram is now like this. Or the parallelogram is like this. Let's make it more stretched out. Something like this. Nowhere it is in a straight manner, right? Now we need to get the height of this parallelogram. No issues. At that time, let's select this as our base. I affirm this as my base. I now need the height. The height should be perpendicular to this base. So what I do, once again, I will take up my, I'll take up my parallel lines. The lines are parallel now. And I now need to have a perpendicular on this one. So the perpendicular will actually fall. One minute. Hand up. This is the perpendicular. Which one? Consa lines, yellow, tell me the color. Yellow color, what do you want to do?
So she's asking if you can extend it downwards.
Extend it downwards means, okay. What is allowed, I'll tell you, okay. This way, height. Okay. The question first arises, okay, you have still, that means the concept of height is not clear. No issues. Let's first clear it up. The concept of height is, in order to find height, you have to first ask, where is the base? Why are you measuring my height like this? You are taking the ground as the base. And what do the people who, your PT sir will tell you, what, stand straight. If you stand like this, can you measure your height? No, that's not height. For height, that measurement has to be perpendicular to the base. So before you ask height, you first select who should be your base. I have selected this as my base. Now with that base, you should be perpendicular. So another way of making it perpendicular would be that I can also make it perpendicular from here. Even this is fine. This is also the height, right? Let's do a little bit more interesting. Let's say, no sir, I'm not happy with the way you are doing. I want to oppose you. And in my opposition, I'm saying that this is the base. This is the base. Now your height has to be perpendicular to it. So your height has to be like this. It has to be perpendicular to the base. If you want to measure this height outside, you can still do this. Now you will be extending it on which side? You will be extending these sides. This as well as this. And now you measure your height anywhere. You can measure the height here also. You can measure it here also. You can measure it here also. Your choice. Height is the distance between, is the perpendicular distance between two parallels. You want to measure my height? Put me between two parallels. What is the first parallel? The ground. The second parallel is hold a string tight from this side to this side, which just touches my head like a tangent. And then measure the difference anywhere. That's my height. You need not always hold it near me. Is this concept getting clear? Because there will be many problems in which you will say, sir, how do I get the height? Height is there. You are unable to visualize it. So we go back here and now we say, this is my triangle. So if the triangle's base is this, now go by the same way. Look at the top triangle. Which is the base? AB is the base. This D is the vertex of the triangle. So first put the triangle between two parallels. So these are the two parallels. And calculate the perpendicular distance between the parallels, which is height, h. Now this is common for whether I'm taking this triangle or I'm taking this triangle. Is this concept clear now? So that's how you get BH. And here you will get LB. But look at the beautiful part of it. Now see the beautiful part of it. I said that a rectangle is also a parallelogram. So the parallelogram's formula should also apply to the rectangle. Is it not the base of the parallelogram? And since this is 90 degrees, is it not the height? So you are actually doing base into height. अगर ये इस पे लागू है, then all the parameters of this should be on this, na? That's it. Which means that if you are very, say you are a child who doesn't love to share, something like my childhood, and be with my sister and chocolates. Somebody gave you a dairy milk of this shape, and suppose the dairy milk It's summer, it has become soft. If you just make the dairy milk little bit parallelogram, you still don't lose out anything on your share because you're eating the same area. Are you getting the beauty part of it? Shape change कर देने से आपको कोई that means when a sweet seller makes a kaju katli or he gives you a rectangular barfi, it is just the cosmetic appeal that you are getting attracted to. He is not losing on any part of the material. वो आपको वही चीज अलग शेप में खिला रहा है. ये shape, I like this shape. So next time, if somebody makes a garment or something or a tablecloth or something from this to this, madam, the design is separate, so the price is different. So be a good student and say, you're not adding any extra fabric. You're adding the same fabric. You're just making it like this. And this length is exactly equal to this length. Are we clear on this thing?
Yes.
Now, one good thing. You've read a little bit about congruent triangles also. Though have you read congruent triangles in 7? No, okay. Leave it. The diagonal of a rectangle, of a parallelogram, divides it into two triangles of equal area. This is another information we are getting. Look at the area of the top, half BH. Look at the area of the bottom, half BH. So the diagonal of a parallelogram divides it into two triangles of equal area. If this is true here, then the diagonal of a rectangle also divides it into two triangles of equal area. It has to be. You don't memorize geometry, you have to understand. Therefore, when you are going and watching this video once again, at that time, try to make your notes. That is how you understand. So you can write that line. Diagonal of a parallelogram, the diagonal of a parallelogram divides it into two triangles of equal area. Diagonal of a parallelogram divides it into two triangles of equal area. And I don't want you to write a single line without understanding. You should be happy first, convinced. Yes, I agree what I'm writing. Otherwise, everything will go inside you like Hebrew and Latin. Did you agree? And the same applies, and the next line, right? And the same applies to a parallelogram also. Sorry, rectangle also. Just that the difference is, in a rectangle, you will get two right angle triangles, whereas here you will get two scalene triangles of equal area. Itna kuch hai. Here we get two scalene triangles of equal area. Here we will get two right angle triangles of equal area. Sorry. Service, just get up. Slowly open the net door. Slowly open the net door and close the glass door. Yeah, close the glass door. It will clamp up. Very good. And now close the net door also. Oh, but I don't want you to run for your cycle. Length and height. Length and height are perpendicular to each other. If you consider this as length, then this will be your height. Length or the base. Length and height will always be perpendicular to each other. No, they cannot give the same formula for each of them. Because here, like the way you say width, width is a measurement which is perpendicular across the lengths. This is not perpendicular. They cannot give the same formula. You can't use L into B out here. B into H is applicable. L into B is not applicable here. But L into B will not be applicable. Look at the area out here, B into H. You are not using this one. You are using this one. Every this is a this, but every this is not a this. Remember that. Every rectangle is a parallelogram. Eh? Every rectangle is a parallelogram, but every parallelogram is not a rectangle. See, if you convert from this to this, then it is 100% truth. But if you convert from this to this, need not be. Need not be. Clear? Can I move up now? We'll come to some special definitions like diagonals, bisect and all. That's later. But first, let us understand the basic shapes and the formulations with respect to them. So what is the area of a rectangle? Laba, and this is Baha. Okay, and in here the diagonal divides in both the case into two triangles of equal area, that we have understood, right? And how to look at height also you have understood, because every time they may not give the shape in this manner, the shape can be disguised and given to you also. And when you find the height, you first ask who is the base. Unless you find the base, like you can't say chor, thief, you can't say. First you have to identify the article which has been stolen, then you can designate somebody as a thief. If the article itself is not designated, then how do you get he's a thief? Something has to be stolen, then the thief will be designated. So when you go for a height, first ask who is the base. Are we fine? Shall we go ahead? Okay. This one has got jumbled up. Jumbled up. No, we can do that. That is not an issue. Yo. Don't worry. Now fine. Okay, let's go. Sir is a little bit old, so use him also sometime. Okay, let's go to the next one. 1, 2. We come to the third one, and this is square. Square. Yes, my English is not good, I'm very poor in my English. So, square is a quadrilateral in which 4 sides are equal, as well as the vertices make 90-degree angle. So, it will be la, ta, 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 and they are also parallel to each other, right? They are parallel to each other. And they have a 90-degree out here. This is A, B, C, D. So in a square, I will have number 1. Here I'll say opposite sides are, yes, this is the necessary criteria, equal and parallel for every side. That's what I said. Now look at the statement. Opposite sides are equal and parallel for every side. Have you understood? All 4 sides. Now try to think. Now, and every vertex angle will be equal to 90 degree. That's my second one. The vertex angles will be equal to 90 degree. Right? That means some very interesting thing and observations that will come up here. If I compare this with a rectangle, every square is a rectangle, but every rectangle need not be a square. Because to form a square, the necessary and sufficient criteria is that not only should you be parallel, your all 4 sides should be equal, and that is where the rectangle will fail out, because the rectangle has a la and a ba, where la and ba are not equal to each other, length and breadth. Whereas in a square, since all sides are equal, I will say that it has only S. And right now, what did you say? Every rectangle need not be a square, but every square is a rectangle. So the formula for area of a rectangle must fit a square. Yes. So what is the area of a rectangle? What is the area of a rectangle? What? L into B. This is my L and this is my B. But in this case, I have a S and I have a S. So it's a S into an S, which is equal to a sine square. Are you getting it? Right. Some more interesting observations. Look. Okay. One more observation and then you can write. If you make a diagonal out here, then you get 2 triangles which are isosceles triangles, because these arms are equal. What is an isosceles triangle? An isosceles triangles are whose 2 sides are angle, and this is a very special isosceles triangle whose vertex angle is also 90 degree. So these are not only right angle triangle, they are also right isosceles triangle. So the best way we say that diagonal of a square divides it into two isosceles right triangles. Divides it into two isosceles right triangles. You understanding? So it's like a lot of things you are learning, easy to learn and easy to forget stuff. They're not tough, but they're easy to learn and they're easy to forget. Even I don't remember them, but as I'm teaching, it gets into my head. And then this fellow will say, sir, next shape, sir, samosa, sir. Then one more will say, sir, onion samosa, sir. That is more like an equilateral triangle. So take a hammer, put his head and dong. श्रेयास बेटा कैसे हो? श्रेयास कहाँ छुप जाते हो? बीच बीच में फोटो बंद कर देते हो, क्या है? कौन सा ब्राउजिंग कर रहे हो? कौन सा चैनल देख रहे हो? फॉर्मूला 1 देख रहे हो? क्या हो गया? टांग का क्या हाल है अभी? दर्द हो रहा है? दर्द तो होगा ही ना वहां पे, उसमें कोई लड्डू थोड़ी लगा हुआ है। तुमको मेडिसिन गया है और आर यू ओनली इनटू अ बैंडेज? तो मेडिसिन है तो क्या दर्द है? तो फेक मेडिसिन है क्या? मेडिसिन खाने से कैसे दर्द होगा? आराम से बैठो, मैगी शैगी खाओ, दिस इज योर चांस। I think our floor has a problem. 1407 one surgery case, 1307 one leg case.
No.
हाँ, he just stays below me ना। पूरा ट्यूशन में प्रॉब्लम है। It is the injured class. ये मैं सब शुरू हुआ किससे? From Mishka. So actually you should bang her head first. हाँ, she is the person. So let's go and now put some analogy out here. So agreed. Now this square was again given a punishment. He did not wear the proper uniform in school. Go and stand in the sun. So as he stood in the sun, the square also become like this. Okay, and that will give you a rhombus. Yes, see now how nice you understand. This is what I wanted you. So out here we have our DC. So this is my DC. Agreed or not? This is my DC. Okay, maybe it has become a little bit more longer than you expected. So this is DC, and the arms of this DC have actually slanted a bit on this side, like this, right? Which makes me draw them in this, and this, and I complete this. And some of the parameters that I now get is that the parallel relation is still restored. The parallel relation is restored, as well as all the sides are equal to one another. That means it is also a parallelogram, but a special parallelogram where all sides are equal. So is every rhombus a parallelogram? Yes. Is every parallelogram a rhombus? No, because in other parallelograms the adjacent sides did not be equal. Out here the adjacent sides are equal. So this gives birth to my next kiddo, whose name is a rhombus. And if you ever have a trouble, this is the same thing which is known as a Kaju Katli. The Kaju Katli is a rhombus. Yeah, those small little cakes that are made up of, a batter of cashew and milk and a little bit of cottage cheese and everything mixed and ground together, made a paste, and then you bake it and you find like this. Kaju Barfi, you understand? It is that Kaju Barfi. So this is called the rhombus. So in a rhombus, what I'll have is that the necessary and sufficient criteria for a rhombus would be all four sides are equal. Yes, and opposite sides are Parallel. Now look at the necessary and sufficient criteria for a parallelogram. Opposite sides must be parallel and equal. Here it says it doesn't fit here. And all sides should be equal. So every rhombus is a parallelogram, but every parallelogram is not a rhombus. And some lovely things that we get out here is that if this fellow is a parallelogram, then he must support the area formula of parallelogram also. So one of the way of finding its area, look, we will not discuss this again. Now look here, I can make the height out here, right? So if I say this as my base and this as my height, then the area of the rhombus can also be written as base into height. But this actually is not this. We don't use this formula. Let us see what formula we use. Okay, let's see what formula we use. The formula that we use is, we will be actually making diagonals. Look, it's very easy. Let's make the diagonals. Now in a rhombus, we will have a major diagonal and a minor diagonal. So this is the minor diagonal, this is the major diagonal, right? The beauty of a rhombus is that the diagonals bisect each other with 90-degree formation. That means this part is equal to this part. Rather, I'm putting tick marks. And this part is equal to this part. Have you understood?
Yeah.
Vertically opposite angle. 190 means all will be 90. Right. Now look at the beauty. Have you understood? The diagonals are bisected. Now let me name this. Let's say this is A, this is B, this is C, and this is D. Okay. And I take a measurement where I'm saying AC, the minor diagonal, as D2, and the major diagonal BD as D1. Right? D1 and D2. Fine. Now children, what you do, you concentrate on triangle ADC. Triangle ADC. And let's try to find what is the area. Area of a triangle is half of the base, half of AC into the altitude. That is OD. Have you understood this or not? I am considering this triangle where this is my base and this is the altitude, because altitude should always make 90-degree. Agreed? Agree? Correct? So let me put this formula. It is half. What is AC equal to, beta? AC is D2. And what is OD equal to? Half D1. Agreed? Half into half makes it how much? 1/4 D1 D2. Do you agree or not? Similarly, now look at this triangle. Triangle ABC. Now let's look at its area. This area will be half of this into this. So its area will also come out as half 1/4 D1 D2. Half of this, half into base into the height. Just remain where I am. Up till here, are you okay or not? All of you agree or not? If there is slight doubt, I'll explain again. Look at this triangle. This is my base. So half into AC, that is half into D2, multiplied by OB. OB is half of D1. So it becomes 1/4 D1 D2. Now the area of rhombus will be when we add these both. Area of rhombus. Abasada. Abasada means ABCD. Don't you think you will add both the areas? Half, 1/4 pizza gives you how much pizza? Half pizza. 2/4. 2/4 is correct, but you don't say 2/4. Quarter pizza is half pizza. Quarter pizza is one pizza. So this is quarter pizza plus quarter pizza. How much is it? Half pizza. So the formula is half D1 D2. This is the formula that we use for area of a rectangle, rhombus. Half into the diagonal into the diagonal. Understood? Later on, when you will calculate areas and all, you will need these. So that 90 degrees, The same difference that you have between parallelogram and rectangle. Parallelogram and rectangles have one criteria, that their adjacent sides are not equal. Here they are more special. Their adjacent sides are equal, and in one case it is 90, one case it is that's it. This one is a rectangle, this one is a parallelogram. Rectangle is not this one, parallelogram is not this one, but this one is a parallelogram because it meets the criteria of a parallelogram. So if you see a rhombus, and every time, let's say we have seen a rhombus, what is the formula of area of a rhombus? Half d1 d2, and you are concentrating only on half d1 d2. लेकिन उस क्वेश्चन में d1 भी नहीं दिया हुआ है, d2 is also not given, but they have specified what is the base and the height. But your goddamn brain is not thinking that this is a parallelogram also. You can use base into height also. We have one problem in grade 8. Many children say, sir, neither diagonal is given, how will I compute the area? You are unable to compute the area because you are not thinking this is a parallelogram. So you can also use a base. It's just like a screw. Need not always you need a screwdriver. You can take a butter knife and also open it. Right? So you can have a butter knife and you can open the screw also. It's not that you always need a screwdriver. And that's the analogy of doing mathematics. Have you understood this much? So 4 things we have seen. These are the basics. Now as we go on, we will take up one more. There's one more shape that we study, and trapezium will come with. Okay, there's one more shape that we see. Okay, you want to do trapezium first, so we'll take trapezium first. Okay, let's take number 5, trapezium. Trapezium is very stylish. A trapezium has got one pair of opposite sides, is only parallel. Nobody talks about they being equal. Okay, so look here, look at a trapezium. My trapezium is something like this. One pair of opposite side is just parallel. It can be, and they're not equal. They're just parallel. So the mark that I make here is that this is the mark. This is a mark, and the other sides is coming almost equal to each other. So I'm deliberately making it here. They also need not be. So it's an irregular what do you call polygon. It's an irregular polygon in which one pair of opposite side is parallel. So is a rectangle a trapezium? Yes. Is a square a trapezium? Yes. Is a rhombus a trapezium? Yes. Is a trapezium a rhombus? Never. Is a rhombus a trapezium a square? Never. Is a trapezium a parallelogram? Never. Is a trapezium a what do you call a rectangle? Never. Because in all those 4 shapes that you saw, one pair of opposite side is parallel, so ये तो criteria तो meet कर जाता है. Abhi you confused? Okay, so let's name this. This is A, right? This is B, this is C, and this is D. And I won't put any symbols because none of the sides are equal to each other, right? Now let's try to find out what is the area of a trapezium. We'll use the same railway line funda. Let's use the railway line funda. So let's make our railway lines ting, ting. Agreed? Okay, then make one diagonal. That's the easiest approach. This is one diagonal. So you have now divided the shape into 2 triangles. Look, this is triangle T1 and this is triangle T2. If you actually add the areas of both the triangles, you should get the area of the trapezium, right? So to find the area of triangle, let's say we are first considering triangle ADC, and you want to find out the area of this triangle. Then what do you need? You need half times base. What do we take as base? We take DC as base, and we need the height. So we are now very, very smart kiddos. We know how to take the height. So we take the height anywhere here. So the height is always making 90 degree with. The height should always make a 90 degree with the base. That's it. Height should make a 90 degree with the base. So let's term this fellow as HR. Okay. So into H. Are we fine? Okay, and if you want to name DC something, let's name DC as B, so it looks more stylish. So this area is half BH. Agreed? And next we take our area triangle. Now we take T1, that will be ABC, Abasa. So in Abasa, what do we get? Half into base. Now my base will be AB. And with AB, I need height. So height is same as H. Haicha. And let's put AB with a name called A. So this is half AH. Now if I add these two, I get, Daddy, was Grandpa Pig finding out the area of a trapezium? And that's ABCD as the sum of the areas of the two triangles. And we would be adding half BH with half AH. And we're not that morons that we don't know how to take common. So we take half common and we take H common and we have a plus B inside. Do you agree? Half AH. Right. So this formula is actually, my daddy had taught me, or my school teacher, so I remember it that way. Half into sum of parallel sides. I always remember it like this, into perpendicular distance between them. It's the same thing. Half into sum of the parallel sides. What is sum of the parallel sides? A plus B into perpendicular distance between them. So half A plus BH. That's the formula of a trapezium. Because people find trapezium's formula, so half A, and then diagonal banao and nikal lo. You understood or not? So if you see, this diagonal technique helps us to find out the area of any figure that you see. All you need to make is make some rectangle railway lines and make their suicidal case between the make them lie in those and make one train. It will come and the area will come out. This is Vande Bharat formula. A plus B is the sum of the parallel sides and perpendicular height is H. So unless you have the perpendicular height, you will not be able to find out. So there was one more shape, that was kite, that we'll do in next class. Don't worry. Kite. Kite is actually a rhombus whose tail end is bigger head. So it's two isosceles triangles which are not same, two different sides. Okay. Before the class ended, she is already gone out. You have some movie or something waiting?